Good evening, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on differentiation using the quotient rule, and in this video I'm just going to take you through an initial example. Okay, so the quotient rule is used when you have a function being divided by another function. So how we tend to write it is if y equals u over v, where u and v are functions of x. So that just means that they are expressions that contain x, functions that have x in them. Then the way that you differentiate that is you do v du dx minus u dv dx all over v squared. Now the numerator of this looks a little bit like the product rule, with one key difference is that it's subtract instead of add, and what that means is absolutely imperative is it has to be the v that goes first. It must be v du dx minus u dv dx, never the other way around, and it's all over v squared. Very importantly, it is always u that is the numerator of the function you're differentiating, and v is always the denominator. Just as a little aside, the fact that u and v are functions of x, you sometimes see this written as f of x over g of x, two different functions of x. So instead of u, they use f of x, instead of v, they use g of x. My preference is for the formula that looks like this. However, this is the version that's given in the formula book. But as always, if you're going to become fluent in using a rule, it makes sense to learn that rule. So learn the quotient rule and use it. Okay, so here's an example. We're going to find dy by dx given that y equals 4x squared minus 1 all over 3x plus 2. And the first thing that we need to do is we need to identify which of those two functions is u and which of those two functions is v. Now u is always the numerator, so I'm going to write that u equals 4x squared minus 1, and v is always the denominator, so I'm going to write here that v equals 3x plus 2. So two different functions of x. 4x squared minus 1 is a function of x that's being divided by 3x plus 2, which is a function of x, so quotient rule. Right, u is 4x squared minus 1, so we're going to differentiate that in terms of x to get du dx, which is 8x, and then we're going to differentiate v to get 3. Now notice here what I do with my v's. I put a little straight line on the end of them, like those trendy baseball caps that kids wear, because it then makes it distinctive from u. And when you're doing a formula that contains v's and u's, it helps to get them as distinct as you possibly can. Okay, now that I've got u and du dx and I've got v and dv dx, I need to write out my quotient rule formula that I'm going to use, because then I can see very clearly how I'm going to substitute into this formula. So v du by dx minus u dv dx all over v squared. So v, which is 3x plus 2, multiplied by du dx, which is 8x, minus u, which is 4x squared minus 1, multiplied by dv dx, which is 3, and that is all over v squared, which is 3x plus 2. That is all squared. And this is the expression for dy dx. So what I'll do, I'll just come up here so you can see it clearly. Dy dx then equals, and I'm just going to expand out these brackets on the numerator. So 3x times by 8x is 24x squared. 2 times by 8x is 16x. Now be careful with the signs when we expand out here. 4x squared multiplied by 3 is 12x squared, but because we've got a minus there, it's negative 12x squared. and then negative 1 times 3 is negative 3, but because of the minus there, it's going to end up being positive 3. And that is all over 3x plus 2 all squared. And I suggest not expanding out the denominator because sometimes it's possible to cancel a term on the numerator, so it helps to leave this in factorised form. Right, so just to tidy up on the numerator then, dy dx is going to be 12x squared, because I've got 24x squared, take away 12x squared, plus 16x plus 3, and that whole thing is over 3x plus 2 all squared. And you could see if this factorises to have a common term with the denominator that you could cancel. In this case it doesn't, so it's fine to leave that as your solution. So if y equals 4x squared minus 1 over 3x plus 2, using the quotient rule, you get dy dx equals 12x squared plus 16x plus 3 all over 3x plus 2 all squared. Join me in the next video where I'll go through another example. I'll see you then.